Now for a more challenging L'Hopital's rule problem involving a different indeterminate form. So our first step is to always do direct substitution. We get 1 over 0 from the right over 1 divided by e to the 0 from the right minus 1. And if you recall our graph for 1 over x, right, this is the graph for 1 divided by x. As we go towards 0 from the right, we are going towards positive infinity. So then the value of 1 over 0 from the right is infinity. And then over here we got 1 over e to the 0. Well, that's a value. That's anything to the 0th power is just 1. So we get 1 over 1 minus 1. So then that evaluates to infinity minus 1 over 0. 1 over 0 is infinity, so we get infinity minus infinity. And this is going to be an indeterminate form. So that means we need to take L'Hopital's rule. But there's one issue, is we don't have a fraction. We have two separate fractions, right? We got this fraction and this fraction, but they're two separate fractions. In order to use L'Hopital's rule, you need one combined coherent fraction. So how do we take two fractions and make them one fraction? Well, we can find like denominators. And you can do that by multiplying by the other thing, right? The other denominator, right? So we multiply 1 divided by x by e to the x minus 1 divided by e to the x minus 1, and then we subtract 1 over e to the x minus 1, and then multiply that one by x over x. And so this is going to give us a like denominator, right? We get e to the x minus 1 divided by x e to the x minus 1, and then minus x over x e to the x minus 1. And so now we can combine both of those, right? We get e to the x minus 1 minus x all over x e to the x minus 1. And so remember, we're still talking about the limit as x approaches 0 from the right. And we're ready to use L'Hopital's rule on it, right? Because we haven't used L'Hopital's rule yet. We've just put it in a form that we can use L'Hopital's rule on. So let's do it. Let's do L'Hopital's rule. Let's take the derivative of the numerator. Derivative of e to the x is just e to the x. Derivative of negative 1 is 0. Derivative of negative x is negative 1. Now in the denominator, we've got a product rule where our first term is x. Derivative of that is 1. Our second term is e to the x minus 1. Derivative of that is e to the x. And then the derivative of minus 1 is 0. So now we go across, and we get e to the x times x plus e to the x minus 1. And then all times 1. But we don't put that, obviously. So now we can resubstitute. Limit as x approaches 0 from the right of that is e to the 0 from the right minus 1 over e to the 0 from the right times 0 from the right plus e to the 0 from the right minus 1. For the numerator, anything to the 0th power is just 1, so we get 1 minus 1. In the denominator, e to the 0th power is just 1 times 0 plus anything to the 0th power is 1, so we get 1 minus 1. So that simplifies to 1 minus 1 over 1 minus 1 equals 0 over 0, which unfortunately is an indeterminate form. But all that means is we just have to take L'Hopital's rule one more time. And so we're taking the L'Hopital's rule of this, right? This is what we're taking the L'Hopital's rule of. So we got e to the x in the numerator. Derivative of e to the x is e to the x. Derivative of negative 1 is 0. And then in the denominator, derivative, this is going to be a product rule, right? So where our first term is e to the x, derivative of e to the x is just e to the x. Our second term is going to be x. Derivative of that is going to be 1. We go across e to the x plus x e to the x. So e to the x plus x e to the x. And then we take the derivative of e to the x, which is just e to the x, and then the derivative of negative 1 is 0, right? So now we can simplify this. We got e to the x divided by e to the, or 2e to the x, right? Because we can combine this term and this term, plus x e to the x. And so this is still the limit as x approaches 0 from the right. So what we can do here is we can factor out an e to the x, right? So the numerator is just e to the x. We'll just leave that. In the denominator, we can factor it out. So we get e to the x times 2 plus x. We're just factoring out e to the x. And then the e to the x in the numerator cancels with the e to the x in the denominator, and then we are left with the limit as x approaches 0 from the right of 1 over 2 plus x, which we can just use direct substitution on, and we get 1 over 2 plus 0, which equals 1/2. So our answer is 1/2.